December 10, 1941, 3 days after Pearl Harbor, off the coast of Luzon, Philippines. USS Swordfish, under Commander Chester Smith, had the perfect shot. A Japanese transport ship, dead in the water, unloading troops for the invasion of the Philippines. Range, 1,200 yards. Conditions, ideal. Smith lined up his attack carefully. This would be America's first torpedo strike of World War II. A chance to show the Japanese what American submarines could do. Fire 1, Fire 2, Fire 3. 3. Mark 14 torpedoes streaked toward the transport. Smith watched through the periscope, waiting for the explosions that would send the enemy ship to the bottom. The torpedoes ran straight and true. They struck the hull, and nothing happened. Smith stared in disbelief. What the hell? Fire 4. Fire 5. 2 more torpedoes, 2 more hits, 2 more, nothing. The Japanese transport continued unloading troops, apparently unaware it had just been struck by 5 American torpedoes. Smith dove deep and retreated, his mind racing. Equipment malfunction? Bad luck? He had no idea that what he'd just experienced would plague American submarines for the next 2 years, cost hundreds of lives, and nearly lose the Pacific War before it truly began. The Mark 14 torpedo was supposed to be the most advanced naval weapon in the world. Developed in the 1930s by the Naval Torpedo Station in Newport, Rhode Island, it incorporated revolutionary technology, a magnetic influence exploder that would detonate the warhead beneath a ship's keel, breaking its back. No need for direct hits, just pass under the target and the explosion would snap the hull like a twig. On paper, it was brilliant. In practice, it was a disaster waiting to happen. The problems started with testing, or rather, the lack of it. The Mark 14 cost $10,000 per torpedo in 1941 dollars, roughly $200,000 today. The Bureau of Ordnance, obsessed with saving money, conducted exactly 2 live fire tests before declaring it operational. Both tests were conducted in the calm waters off Newport against stationary targets. Both torpedoes exploded. Success. Nobody tested it in combat conditions. Nobody tested it at varying depths. Nobody tested it against moving targets. Nobody tested the magnetic exploder in the Earth's magnetic field variations found across the Pacific Ocean. They just assumed it would work and sent it to war. Submarine commanders began reporting problems immediately. Commander Tyrell Jacobs of USS Sargo fired 13 torpedoes at a Japanese convoy in January 1942. All 13 either missed, ran too deep, or failed to explode. He surfaced and attacked with his deck gun instead, a humiliating backup for a submarine supposedly armed with the world's best torpedoes. Commander Howard Gilmore of USS Growler fired 11 torpedoes at perfect range against a Japanese cruiser. Every single one passed harmlessly beneath the target without exploding. The magnetic exploder, designed to sense a ship's magnetic field, apparently couldn't detect Japanese warships. Commander Dudley Morton of USS Wahoo, who would become one of America's most aggressive submarine captains, fired 16 torpedoes in his first 2 patrols. He achieved exactly 0 sinks. Morton was so furious he wrote in his patrol report, "The torpedo performance has been awful. We have lost the element of surprise, expended torpedoes, and risked the crew for absolutely nothing." The complaints flooded into Pearl Harbor and Washington. Dozens of submarine captains, all reporting the same problems. Torpedoes running 10 to 15 feet deeper than set, passing harmlessly under targets. Magnetic exploders detonating prematurely when nowhere near the target. Contact exploders failing to detonate even on direct hits. Torpedoes that ran in circles, nearly sinking the submarine that fired them. The Bureau of Ordnance's response was stunning. The torpedoes are perfect. You're just bad at aiming. Rear Admiral William Blandy, chief of the Bureau of Ordnance, issued a statement that would become infamous. The Mark 14 torpedo is the finest underwater weapon in the world. Reports of failures are the result of poor shooting by undertrained crews and commanders making excuses for their own incompetence. Submarine commanders were livid. These weren't rookies. These were Naval Academy graduates, experienced officers who'd spent years training for exactly this mission. And they were being told that 5 torpedoes striking a stationary target and failing to explode was somehow their fault. The breaking point came in June 1942. Commander Lawson Ramage of USS Trout stalked a Japanese aircraft carrier for 6 hours, maneuvering into perfect position for a broadside shot. He fired a spread of 4 torpedoes at 800 yards, so close he could read the carrier's name through the periscope. All 4 torpedoes struck the carrier's hull. The crew heard the metallic clang of impact, and then, nothing. The carrier sailed away, undamaged. Ramage surfaced that night and radioed Pearl Harbor with a message that violated every protocol. The torpedoes are defective. I don't care what Bureau of Ordnance says. Something is catastrophically wrong, and men are dying because of it. Admiral Charles Lockwood, Commander Submarine Force Pacific, had heard enough. He ordered his own investigation. In August 1942, at the submarine base in Pearl Harbor, Lockwood assembled a team of submarine officers and engineers. They were going to test the Mark 14 themselves, procedures and protocol be damned. They hung a fishnet across the mouth of Pearl Harbor at a measured depth. Then they fired torpedoes set for 10 feet depth at the net. The torpedoes tore through the net at 21 feet depth. They ran the test again, and again, and again. Every single torpedo ran 10 to 12 feet deeper than its depth setting. The problem was the depth sensor, a simple mechanical device that used water pressure to control the torpedo's diving planes. But it was calibrated based on the torpedo's speed during testing. Slow, careful runs in controlled conditions. In combat, torpedoes ran at maximum speed, 46 knots. The increased water flow over the sensor caused it to read incorrectly, making the torpedo think it was shallower than it actually was, causing it to dive deeper. It was a fundamental design flaw that would have been caught with proper testing, but proper testing would have required firing expensive torpedoes. So instead, the Bureau of Ordnance had sent thousands of men to war with a weapon that couldn't hit its targets. Lockwood immediately ordered all submarine commanders to set their torpedoes 10 feet shallower than the target's draft. Problem 1, solved, at least partially, but the torpedoes were still failing to explode. Even with the depth problem fixed, submarines were reporting direct hits that resulted in duds. The torpedo would strike the target, the crew would hear the impact, and then nothing. The ship would steam away with a dent in its hull and a very angry submarine diving deep to avoid the counterattack. The Bureau of Ordnance insisted this was impossible. The contact exploder had been thoroughly tested and was absolutely reliable. Commander Howard Gilmore decided to test that claim himself. In September 1942, at the submarine base in Brisbane, Australia, Gilmore obtained a practice torpedo, identical to a warhead but filled with sand instead of explosives. He fired it at a cliff face at full speed to simulate striking a ship's hull. The torpedo hit the cliff and broke apart. Gilmore's crew retrieved the pieces and examined the contact exploder. They found the problem immediately. The firing pin was too light. When the torpedo struck a target head-on at 46 knots, the sudden deceleration caused the firing pin to lag behind due to inertia. Instead of being driven into the primer to trigger the explosion, the pin actually moved backward, away from the primer. The faster and more direct the hit, the more likely the torpedo was to be a dud. It was the most absurd design flaw imaginable, a weapon that failed specifically when it hit its target perfectly. Gilmore's crew machined a heavier firing pin from spare parts. They tested it against the cliff. This time, the practice torpedo's primer fired. They'd fixed problem 2. But there was still problem 3, the magnetic exploder. This was the most complicated issue. The magnetic exploder, called the Mark 6, was designed to sense changes in the Earth's magnetic field caused by a ship's steel hull. When the torpedo detected this change, it would explode beneath the keel, supposedly breaking the ship's back. Theoretically brilliant, in practice, a nightmare. The Earth's magnetic field varies by location. It's different at the equator than at the poles. It varies with depth. It's affected by underwater volcanic activity, or deposits, even the time of day. The Mark VI had been calibrated for the magnetic conditions in the North Atlantic near Newport, Rhode Island. The Pacific Ocean had completely different magnetic characteristics. The Mark VI was detonating randomly, sometimes too early, sometimes too late, sometimes not at all. Commander Morton of USS Wahoo conducted an unauthorized test in December 1942. He deactivated the magnetic exploder entirely, relying only on the contact exploder, now with the heavier firing pin. His next two patrols resulted in 17 confirmed sinks. Word spread through the submarine fleet. Captains started quietly disabling the magnetic exploders without telling anyone. Suddenly, sinking rates increased dramatically. But this was all unauthorized. Officially, the Bureau of Ordnance still insisted the Mark XIV was perfect and any failures were the fault of submarine crews. Finally, in June 1943, Admiral Lockwood had enough evidence to force action. He wrote a scathing report documenting all 3 design flaws, including detailed test results and recommendations from multiple submarine commanders. He sent it directly to Admiral King, Chief of Naval Operations, bypassing the Bureau of Ordnance entirely. King read the report and exploded with rage. Not at Lockwood, but at the Bureau of Ordnance. He ordered an immediate investigation and personally authorized submarine commanders to disable the magnetic exploders and modify the depth settings. The Bureau of Ordnance, humiliated, finally admitted there might be minor issues with the Mark XIV. They issued new firing instructions in July 1943, 20 months after the problems were first reported. The results were immediate and dramatic. In 1942, American submarines fired 1,442 torpedoes and sank 180 ships, a success rate of about 12%. In the second half of 1943, after the fixes, American submarines fired 3,937 torpedoes and sank 335 ships, a success rate over 30%. By 1944, with all 3 problems resolved, American submarines were sinking Japanese shipping at a catastrophic rate. Japan's merchant fleet, which had started the war at 6 million tons, was being destroyed faster than it could be replaced. The statistics tell the story. 1942. 180 Japanese ships sunk 1943. 335 ships sunk 1944. 603 ships sunk 1945. 416 ships sunk in 8 months before surrender. Total, over 1,300 Japanese ships destroyed by American submarines. More than 5 million tons of shipping sent to the bottom. Japan's oil imports dropped 90%. Their food imports collapsed. Their war industry starved for raw materials. American submarines, once the laughingstock of the Navy with their broken torpedoes, had become the most effective anti-shipping force in naval history. They'd strangled Japan's economy, isolated their forces, and made victory inevitable. But at what cost? The 2-year delay in fixing the Mark XIV's problems had catastrophic consequences. Historians estimate that American submarines could have sunk twice as many ships in 1942 to 43 if the torpedoes had worked properly. That's potentially 500 to 700 additional sinkings. Those ships carried reinforcements, supplies, and equipment to Japanese forces throughout the Pacific. They delivered troops to garrisons that American forces would later have to assault at great cost. They brought food, medicine, and ammunition that kept Japanese resistance alive. How many American lives were lost because those ships weren't sunk in 1942? How many battles could have been won more easily? How much shorter could the war have been? We'll never know. But we do know this. 52 American submarines were lost during World War II. Many of those losses came in 1942 to 43, when submarines had to make multiple attacks because their torpedoes wouldn't work. Each additional attack meant more time on station, more exposure to enemy counterattacks, more opportunities to be detected and destroyed. How many of those 52 boats were lost because they had to fire 10 torpedoes when 2 working ones would have been enough? The submarine force lost 3,505 men during the war, the highest casualty rate of any U.S. military branch. 22% of submariners who deployed never came home. Commander Howard Gilmore, who'd discovered the firing pin problem, was killed in action in February 1943. His last words, after being wounded on the bridge during a surface action, were, "Take her down." He ordered his submarine to dive, knowing he couldn't make it below in time, saving his crew at the cost of his own life. He was awarded the Medal of Honor posthumously. But some say his greatest contribution was spending hours testing torpedoes against a cliff face until he found the design flaw that the Bureau of Ordnance had missed. Commander Dudley Morton, the aggressive captain who'd written scathing reports about torpedo failures, was lost with all hands aboard USS Wahoo in October 1943. His submarine was sunk by Japanese aircraft in the La Perouse Strait. Morton had sunk 20 ships in his career, but only after he'd started disabling the magnetic exploders without authorization. How many more ships could he have sunk in 1942 if his torpedoes had worked? How many more patrols could he have survived if he hadn't needed to make repeated attacks? The Bureau of Ordnance never officially apologized. After the war, Rear Admiral Blandy, the man who'd insisted the torpedoes were perfect and blamed submarine captains for failures, was promoted to Vice Admiral Blandy Admiral and given command of Atlantic Fleet operations. The torpedo station at Newport continued operating. The engineers who'd designed the faulty depth sensor, weak firing pin, and unreliable magnetic exploder faced no consequences. Many retired with full pensions and commendations for their service. But among the submarine force, the Mark 14 disaster became a legend, a cautionary tale about bureaucratic arrogance, insufficient testing, and the cost of ignoring field reports from the men actually fighting the war. In 1944, a young submarine officer named Hyman Rickover watched the Mark 14 scandal unfold. He was appalled by the Bureau of Ordnance's incompetence and their refusal to listen to operators in the field. 20 years later, as Admiral Rickover, he would revolutionize the Navy by developing nuclear submarines. His management philosophy was shaped by the Mark 14 disaster. Test everything exhaustively. Listen to operators. Question assumptions. Never assume that because something works in theory, it will work in combat. The nuclear submarine fleet, the most successful naval force in history, was built on lessons learned from a torpedo that didn't work. Today, the Mark 14 torpedo is displayed at the Submarine Force Museum in Groton, Connecticut. The placard describes it as the most infamous torpedo in U.S. Navy history. Next to it is a quote from Admiral Lockwood, written in 1945. The Mark 14 torpedo, as originally designed, was a brilliant piece of engineering that didn't work. It took the courage of submarine commanders willing to question authority, conduct unauthorized tests, and modify equipment against orders to turn it into a war-winning weapon. The real story of the Pacific Submarine War isn't about technology. It's about the men who refused to accept failure and fixed the Navy's mistakes themselves. The final tally. American submarines, once armed with broken torpedoes that made them a joke, ended the war as the most lethal anti-shipping force ever deployed. They sank 1,314 Japanese ships, destroyed Japan's merchant marine, and isolated the home islands completely. 30% of Japanese warships were sunk by submarines. 55% of all Japanese merchant shipping, including 8 aircraft carriers, 1 battleship, and 11 cruisers. All with a weapon that didn't work correctly until submarine commanders fixed it themselves, 2 years into the war, against the explicit orders of the Bureau of Ordnance. The Germans called American torpedoes defective junk in 1942. By 1945, German submarine commanders were studying American submarine tactics and trying to understand how the U.S. had achieved such devastating success. The answer was simple. American submariners refused to lose with broken equipment. They identified the problems, fixed them without permission, and turned the worst torpedo in the world into the weapon that won the Pacific War.